You're watching CTOM TV. Knowledge is power.
So now we're going to get into the actual treatments. So when we first started treating multiple myeloma, there was a class of drugs called proteasome inhibitors, and they really made a big difference in treatment. Fairly old drugs. The first one was bortezomib, and that was combined with cyclophosphamide, which is a very old drug, and once again dexamethasone. So pretty well every multiple myeloma protocol is going to include dexamethasone. Mm-hmm. It's just the standard component in that treatment. So I won't mention it again. Okay. It's always going to be there.
All right.
So in the standard treatment is called VCD, mm-hmm. and that is bortezomib is also known as Velcade.
Okay, that sounds easier to say.
That's why it's called VCD. I have
see.
a problem saying this because I have a cold sore right now.
Oh,
not a cold sore. I bit my lip.
Oh no!
So I may
canker sore or something.
Yeah, canker sore. I may be stumbling with my pronunciations.
Okay, we can all say Velcade.
Velcade
That's
is
much
nice.
easier.
Yes,
Mm-hmm.
yes. So these drugs are called proteasome inhibitors, and this is the first milestone we've made with multiple myeloma, is adding these to the treatment protocols. And so the bortezomib, I think, affects the 26S proteasome, and then there's a new drug called carfilzomib. Carfilzomib. It's a proteasome inhibitor, and it targets a different proteasome, I believe the 20S proteasome. And so what happens by targeting these proteasomes? So proteasomes break down what's called polyubiquitinated proteins. So they're kind of like the garbage disposals in your sink, these proteasomes. They break down, used proteins and things circulating in the blood. Okay. And as you know, the biggest problem with multiple myeloma is having all of this junk floating around. Mm-hmm. So these drugs inhibit this process of these proteasomes from breaking down this extra stuff. And what that does is it ends up the cancer cells get a buildup of these polyubiquitinated proteins, and they die from it.
Oh, it's kind of counterintuitive.
It is. It's like, it's like leaving the garbage to build up in a certain area to kill the rats.
Got it. Wow.
And so the result is apoptosis. So that's how those proteasome inhibitors actually work.
How does it affect the rest of the body while this is
happening? The cancer cells, the multiple myeloma cells, are going to be more susceptible because they're producing a mass amount of these useless proteins, and they're doing it 24/7. Oh. So it's going to affect them much more than other cells. So these drugs work quite well. So that was the first development in multiple myeloma. And then, of course, they came into the thalidomide derivatives. Mm-hmm. The one that works really well now is pomalidomide. So the VCD, the Velcade, cyclophosphamide, and dexamethasone has been fairly standard since, I think, about early 2000s, 2004, 2006, depending on which country you're in. Recently, they've switched it up and added thalidomide, and they call that VTD. VTD came out in about 2004. Okay. And so VTD is much better than VCD. So for overall response rates in patients, I believe VTD gives you a response rate of about 92, 93% versus 83 for VCD, which is so you're replacing the old chemotherapy drug cyclophosphamide with the thalidomide.
Got it.
And so you have less side effects. And so then, of course, carfilzomib came along, and that's a better drug than bortezomib. So that's the second generation of it. Mm-hmm. And then the third generation of the thalidomide derivatives is pomalidomide. And so that's really improved things.
Mm-hmm. And when did that come about?
Oh, quite a few years ago.
Okay, so about 2004 as well. That
no, I don't quite recall.
Not quite.
It was probably,
since that's the third generation. Okay.
I'm not sure.
All right.
I'm gonna have to look that up.
The reason I'm asking that for folks at home is because one of the points we like to make when we get a chance to talk to someone with cancer is that there's new treatments coming out all the time.
Yes.
You know, Alex just talked about you know, quite a difference in outcome for people just over the span of even 4 years, depending on whether they're getting what was standard.
Try a few months.
Try a few months. It's true.
It's pretty crazy these
Yeah,
days.
it really is. Mm-hmm.
So now let's get into the latest and the best.
Okay.
September
All right.
2019.
Woo, that is very latest.
FDA approved a new drug called daratumumab.
Okay.
This is a monoclonal antibody that, and this is a new addition for multiple myeloma, is targeting a cell surface protein called CD38.
Okay.
And so when you target CD38, it's preferentially expressed in multiple myeloma cells. When you target this and you add that to the standards, you know, such as VTD, the new standard that is, not
Yes.
VCD, but
Right.
VTD.
Mm-hmm.
You know, I think they may still use VCD in Canada. I'm not 100% sure, but I have heard of.
Again, you can petition, even if you're in Canada or
ask
other
for
countries.
VTD.
You can
Ask for VTD.
advocate
Yes.
for different treatments and stuff.
Yes. So, FDA approved that because of the trial was just working so well.
Wow.
And so when they added this drug, this daratumumab,
Okay.
this CD38 inhibitor, when they added that in newly diagnosed patients that were eligible for stem cell transplants, they got a 53% reduction in death, which is really significant. Very, very significant.
Wow, I can see why they approved this.
Yeah, so now you have Velcade, thalidomide, Dex, and daratumumab. So it's got D-VTD.
Okay.
And so 53% reduction compared to VTD alone. So just adding that one drug. So targeting the CD38 axis is really, you know, the new way to go. So, you know, all patients should get that. And then just recently, a new drug called selinexor. It was newly FDA approved. I'm not sure if it's been approved for prime time yet, or if it's just been given, you know, a designation. But that's another CD38 monoclonal antibody, and that is, you know, works similar to daratumumab. So we have a couple of different players there, and we'll probably see a lot more.
You mean different pharmaceutical companies have developed something that works on that same. Now, tell me again, CD38, is that a chromosome? Is that a gene?
No, it's a protein.
It's a protein.
Yeah, it's targeted.
Okay.
It's unique to, not unique, but it's preferentially expressed.
And what are these drugs doing to that protein?
So the way they work with all monoclonal antibodies, they work in a similar manner. Now, we don't entirely understand how they work. And it gets very complicated quickly. But what they do is they bind onto that. So they bind onto that, and they're large molecules. And then when they bind onto this, they, you know, all of a sudden the immune system goes, hey, what's that big piece of junk on the outside of that cell? That's not supposed to be there. Let's just destroy the whole thing. So it's called antibody, or, you know, cytotoxic mediated targeting.
Okay.
But basically, that's one of the processes that we believe the way these drugs work.
So it potentially just forces the immune system to notice what's going on.
Yeah.
Excellent. Wow.
One of the processes, and also having this drug attached to the CD38 receptor obviously is going to prevent it from functioning. So now its ligand can't bind, so you get what's called steric hindrance.
Which is?
Steric hindrance is if you go to park in a parking lot and you have a designated parking spot and you go in there and there's a truck in your parking spot, you can't park in there.
Damn.
So you have to, you know, that's a hindrance.
Got it.
That's steric hindrance.
And we want to hinder these things.
Yes, we
do.
Yes.
Wow. So adding this daratumumab
or selinexor.
Or selinexor, I couldn't pronounce that one with confidence, has already massively reduced death in these multiple myeloma patients. Wow, that's exciting.
And they're using it in first line, newly diagnosed.
Excellent. Now, who are they? Where is this happening? Is this like in one, like for example, is it like Mayo or MD Anderson, or is it kind of nationwide in a particular country, or is it just recommended?
Well, I think all of these clinical trials are international.
International.
Yeah, all clinical trials these days are international.
So it's recommended for first-line treatment.
That's a sticky question.
More so sticky.
Well, it depends on where you are.
Okay.
Depends on the hospital.
What
depends
I'm saying
on
is
many
the
factors.
study and the FDA in approving this treatment are saying you could use it and probably should for first line, whether certain governments are picking that up or certain provinces are picking that up or not.
FDA approval means you should use it.
Okay, so point is, there's a study out there that you could show your oncologist that says, hey, look, these peer-reviewed scientists and the FDA are saying this should be first line.
Well, if the FDA is saying you should use it, you should use it.
Mm-hmm.
I mean, that's a given. You know, they're pretty conservative. Mm-hmm. And they don't like to approve things very often. So, so if the FDA is saying that, you know, there's undisputable proof that it's going to be beneficial.
Mm-hmm. That's great news.
Yeah.
Wow. Okay. Anything else you want to tell us about
this? No,
I think
that pretty well sums it up.
Okay. That's actually really far better news than I thought I was going to hear about this disease and the current research. So summing it up, we have standard diagnostic protocol or assessment protocol, which is that CRAB, which we want to add some genetic testing to see if you're one of those high-risk patients, because that can then expedite your treatment. It can and make your oncologist provide you with treatment faster or help them to have more confidence that they should.
Well, even if you're low risk, I would get treatment.
I understand. And then there's the Mayo Clinic process of the 20-20, which you want to make sure that your doctor is also applying to you to determine how and when to treat you. And there's this new DVTD treatment protocol that is saving lives in ginormous proportions.
Well, I think the best way to look at this is look at the targets of multiple myeloma. So you have proteasome inhibitors, and there's going to be better and newer drugs. You know, carfilzomib is already one of those. And there's going to be increases in that area. So companies are going to develop better proteasome inhibitors. Then there's the you know, thalidomide derivatives. We have 3 of them right now, and that's another target.
They keep refining that.
And they keep refining that. And then there's the CD38 inhibitors. And so there's going to be just a bunch of different players in all 3 classes. So the trick to do it is, you know, if I had multiple myeloma, what I would do is I'd find out the best proteasome inhibitor. I would find out the best version, which is probably pomalidomide, of the thalidomide derivatives. And then I would look into the best CD38 monoclonal antibodies and just make my own custom panel. You know, pick the best of each. So I'll take that. I'll take that and new CD38 inhibitor. I'll take that one. Yes.
That might sound like a tall order, which is why Alex is here.
Well, it's important to consider that when these drugs come out, the drug companies often provide the drug for free. You know, they often, there's this grace period where they're saying, hey, we'll give this drug to anybody.
Because they want more people on it.
Exactly.
To prove how well it works.
Exactly. And they want to show the medical systems, hey, we've got this great new drug that works really well. So there's opportunities above and beyond what your local cancer agency is offering to make these combinations yourself. We do it all the time. We'll pick the best of drug A, the best of drug C, and the best of drug D. Even if those drugs are not approved together, we know based on defined mechanisms that there's an incredibly high chance each one of those drugs is going to be incredibly beneficial. And while they haven't been tested in that exact combo, very rarely do we see that protocol or that process not working much better.
And we find increasingly over the 10 plus years we've been doing this work that because oncologists are increasingly understanding the value of genetic testing and how rapidly the research is progressing and how rapidly new treatments are coming onto the market, we find that even if they're offering you a certain treatment, might be, you know, old standard, they are increasingly open-minded to these kinds of create your own combo based on your genetics and what your risk is. So just because your oncologist has said this is what we have to offer you does not mean that if you were to present them with a little more information that they would be closed to helping you to access those treatments. In fact, we find oncologists, again, are increasingly supportive, but they need the evidence. You have to often take it upon yourself to get the genetic testing, to get the added data, and to provide them with the studies and the proof. And that's what Alex and his team do. Yeah, they just do all the research, gather all the tests for you, put together a report, deliver that to you, and then also to your oncologist in consultation, so that they have confidence with what's being recommended if it's different. And you're not only helping yourself, but that's helping your oncologist to more rapidly assimilate this new technology, and it really benefits a lot of other people too.
Thank you for watching Cetome TV. Subscribe below and stay informed.